Welcome students. Today our topic is construction of overhead lines. In a previous lecture, we are discussed about the overhead construction line, overhead lines. The basic requirement for the construction overhead line that is the survey. So a transmission line is one of the essential infrastructure to the supply system. In the site evaluation process for those facility, it is necessary to carefully consider not only technical issue but also the impact on natural environment and the influence on local communities and the various regulations to achieve optimum length and minimum, or we can say that minimize rocky and water terrains, reduce tower angle, cut points and right of way issue, etc. we have to consider, and it is necessary to have detailed survey and the profile of transmission line route. Now the question is that the why survey is important. So it is important because to optimize cost of the transmission line. So by the survey we can decide the transmission line length and the number of location and the deviation which are in our transmission line, and we are going to avoid that the minimize river crossing and the minimum forest area we have to consider, including that the accessibility and the right of way consideration we also have to consider. Now by this the transmission line cost is economy. Now to ensure saturated clearance, now the ground clearance we have to there and horizontal or right of way clearance have to be there, and clearance from the power lines. If there is a crossing, the power line is also already there, so we have to take a clearance from them also. Now also that the project feasibility stage, pre-construction stage and the project construction stage also be there, and that in the project construction stage we are checking the survey only. Now when we talk about the detailed survey, or we can say that the modern technique we are using, that is the route alignment using latest satellite images superimposed on survey of India topographical maps. We already discussed about the topo maps. Digital terrain modeling in hills using countering data, detailed survey using GPS, total station and ALTM, digitalize countering and hilly tower locations, identification of route constraints, identification of infrastructure detail, tower spotting and optimum of location, commercial software like PLSCAD, estimation of BOQ and preparation of survey reports, and soil investment. These are the modern technique. By this the detailed survey have to be done. Now for the when we talk about the modern techniques, we are using the three modern techniques which are written here, that is a global positioning system, GPS in short we already know, total station and PLSCAD. A global positioning system GPS is a space-based satellite navigation system that provides location and time information in all weather, anywhere on or near the earth where there is an unobstructable line or a site GPS satellite. It is a modern technology that improves survey engineering to global orientation. We all know about the GPS, how GPS work. In our smartphone GPS is also there. When we have to go somewhere else, we can just open the map, Google map especially, we are knowing that, and we are reach our destination with the help of GPS. Now the total station is a modern surveying instrument that integrates an electronic theodolite with an electronic distance meter. A theodolite uses a movable telescope to measure angle in both the horizontal and vertical planes. Coordinates of unknown points relative to known coordinate can be determined using the total station. Now PLSCAD power line system or computer aided design and drafting. It is a software that we are drafting, which we are using in a computer system. That is PLSCAD is the most powerful overhead power line design program. PLSCAD is a sophisticated three-dimensional engineering model. The model can be viewed in a number of different ways: profile view, plan and profile sheet, and 3D view, etc. PLSCAD support both automatic and manual spotting. Now, when we have the detailed survey, it includes that fixing of alignment, fixing of line points, fixing of angle of deviation, fixing of angle points, fixing of direction points, measuring of distance between angle points, level at every 10-meter interval, or where there is a level difference of 30 centimeter. So these are by the detailed survey. Uh, Now also the detail of roads, detail of village, PNT line crossing, all power line crossing, railway crossing, river crossing, agricultural well, field burns and earth burns, etc. Measuring soil resistivity at 1 kilometer interval, trial pits, crop and tree enumerations. All these things are be considered in the detailed survey. And the obligation points in the detailed survey is that we have to avoid something that is a reserved forest area. We have to avoid military firing range. We are avoiding aerodromes. We are avoiding inhabited and thickly populated areas. We are avoiding hilly terrain. We are avoiding marshy, low-lying and submersible areas. We are avoiding, and higher and 90-degree angle turnings and oil and gas storage area. These we are avoiding. And the line profiles included in the detailed survey is that they indicate all power line crossing, indicate all PNT line crossing, indicate all railway crossing, indicate all river crossing, all road crossing, all villages, all agriculture wells, field burns, ponds and lakes, soil, crops and trees. These all things are we are just indicated in the line profile. Now, when we talk about the tower spotting, it is that they identify the spot of terminal tower, start from terminal tower, match the tower footing curve with position of TNT, adjust the position of templates, ensure ground clearance, identify the position of next tower, move the template to the next tower, and repeat this procedure. So these all are considered in the tower spotting. Now, when we talk about the transmitted towers erection, we have a few methods that these are the build-up method or a piecemeal method, section method, ground assembly method, and a helicopter method. These four methods are there to transmitted tower erection. When we talk about the build-up method, this method is most commonly used in India for the erection of 66 kV, 132 kV, 220 kV, and 400 kV transmission line towers. This tower consists of erection, the tower member by member. The tower member are kept on ground serially according to erection sequence to avoid surge or time loss. The erection process from the bottom upwards. The four main corner leg member of the first section of the tower are first erected and bolted with the stub. Now, the cross braces of first section which are already assembled on the ground are raised one by one as a unit and bolted to the already erected corner leg angles. Now, the cross braces of the first section which are already assembled on the ground are raised one by one as a unit and bolted to the already erected corner leg angles. The member or section are hosted either manually or by winch machines operated from the ground. After the tower top is placed and all side lacing are bolted up, cross arm are erected as complete unit. Now, the section method of transmission tower erection. In this section method, major section of the tower are usually assembled on the ground as the same as are erected as unit. These units are erected with the help of mobile cranes. In the ground assembly methods, this method consists of assembling the tower on ground and erecting it as a complete unit. The complete tower is assembled in a horizontal position on even ground. In India, this method is not generally adopted because of prohibitive cost of mobile cranes and non-availability of good approach road to tower locations. Now, the last method is that the helicopter method. In this method, the transmitter tower is erected in sections. Sometimes a completely assembled tower is raised with the help of helicopter. You easily see in the image. This method mostly used where access to a tower location is limited. Now, tower erection, we have a finishing work also there. All nut shall be tightened with 1 to 2 thread shall be projected outside the nut. Punching after nut tightening and track welding shall be done along with bolt and nut together to ensure that the nut are not loosened in course of time. The joint shall be painted with zinc paint and all contact surface during the course of erection to avoid rusting. The final erected tower shall be truly vertically after erection. Tolerance limit for vertical shower shall be in 360 of tower height. Now, this is the construction of a tower which is in progress. The tower have a 4 legs and it is in the construction process. Now, electrical transmission tower types and design. The main supporting unit of a overhead transmission line is the transmission tower. Transmission tower have to carry the heavy transmission conductor at a sufficient safe height from ground. In addition to that, all tower have to sustain all kind of natural calamities. So transmission tower design is an important engineering job where all three basic engineering concepts, civil, mechanical and electrical engineering concepts are equally applicable. Now, a transmission tower consists of the following parts: peak of transmission tower, cross arm of transmission tower, boom of transmission tower, cage of transmission tower body, leg of transmission tower, and bolt and base plate of a transmission tower. Now, when we talk about the peak of a transmission tower, the portion above the top cross arm is called peak of tower. Generally, earth's shielded wire connected to tip of this peak. You easily see that we are talking about that portion. You see orange color in this image. Now, the cage of a transmission tower is the portion between tower body and peak is known as the cage of transmission tower. This portion of the tower holds the cross arm. You easily see in this figure, it is we call the cage. And the cross arm of transmission tower, you know that the portion from the bottom cross arm up to the ground level is called transmission tower body. This portion of the tower play a vital role for maintaining the required ground clearance from the bottom conductor of the transmission line. So, we call it tower body. Now, when we talk about the design of a tower, the minimum ground clearance of the tower conductor point above the ground level, we have to consider that thing also. And the length of the insulator string, the minimum clearance to be maintained between conductor and tower, and the location of ground wire with respect to outermost conductor. These 4 points we have to consider during design of a transmission tower. Now, when we talk about the transmission tower, to determine the actual transmission tower height by considering the above points, we have divided total height of tower in 4 parts. That is, minimum permissible ground clearance, we denoted it by the H1. Maximum sag of the conductor, that is we are denoted by H2. Vertical spacing between top and the bottom conductor, that is which we are denoting by the H3, and the vertical clearance between ground wire and the top conductor, that is H4. Now, we have, according to different consideration, and there are different type of transmission tower. The transmission line goes as per available corridors. Due to unavailability of shorter distance straight corridor, transmission line has to deviate from its straight way when obstruction come. In total length of a long transmission line, there may be several deviation points. Now, We are dividing our transmission tower in a 4 categories. That is A-type tower, which have the angle deviation of 0 to 2 degree. B-type tower, which have the angle of deviation from 2 to 15 degree. C-type tower, which have the angle deviation 15 to 30 degree, and the D-type tower, that is 30 to 60 degree. As per the force applied by the conductor on the cross arm, the transmission tower can be categorized in another way, that is tangent suspension tower. It is generally A-type tower, and the angle tower or tension tower. Sometimes it is called section tower also. It is considered that B, C and D categories of transmission tower. Apart from the above customized type of tower, the tower designed to meet special uses, that is river crossing, railway or highway crossing tower, transportation tower. And based on number of circuit, we have a single circuit tower, double circuit tower and the multi circuit tower. That's all for today. The next topic of the construction overhead line we are discussing in the next class.